1, 2, 3, come on!
Come on, come on. Come on, come on.
Okay, let's have factoring difference of two squares. So it means difference of two squares means subtracting two different perfect square. So for example, we have a squared minus b squared. So this is difference of two squares because a squared is a perfect square and b squared is a perfect square. So this is minus because it refers to the word difference, the process. Okay, so you cannot say difference of two squares if one of the two terms are not, or if one of the two terms is not a perfect square. For example, we have a cubed minus b raised to 4. So this is a perfect square, but a cubed is not a perfect square. So you cannot factor this one. Okay? So I'll erase that one. So a squared minus b squared. So how to factor difference of two squares? So in my class, I have step A. You get the square root of the first term, which is a squared, and also square root of the second term, which is b squared. Square root means the term here will be raised to 1/2. So a squared can be written as raised to 1/2. B squared will be raised to 1/2 also. So multiply the exponent 2 times 1/2 is equal to 2/2 because 2 times 1. So don't multiply 2 to the denominator. 2 be multiplied to 1 only. The same with the process below. So 2/2. So a raised to 2/2 is equal to a raised to 1, or shall we say a. The same also with b squared. B raised to 2/2. So 2/2 is 1. So the answer is b. So a and b. Now what is the use of that a and b? So according to the rule, a squared minus b squared is equal to, use the two, a, b, then put plus and minus. So how come that this is, or these are the factors? So let's prove. Now let's prove how come that a squared minus b squared is equal to the quantity of a plus b times the quantity of a minus b. So before that, sometimes my students will ask, "Sir, my classmate answer a minus b, then a plus b. So is it correct?" So yes, this is correct. So a plus b, a minus b, or a minus b, a plus b. So no need to ask that one because they are the same. Okay. So how come that a squared minus b squared is equal to the quantity of a plus b times the quantity of a minus b? So let's multiply. So proof. So a plus b, then a minus b. So let's do the FOIL method. So FOIL method. So F stands for first, O stands for outer, I stands for the inner, and L stands for the last. So let's multiply first the first. So first means this a and this a. So a times a. Next, outer, a and minus b. So plus a times minus b. Next, the inner. So inner means this one, b and a. So b times a is ab, or ab. And L means last. So plus this one, b times minus b. So evaluate or simplify. So a times a is a squared. Then a times negative b is negative AB, plus A times B is AB, plus B times negative B is negative B squared. Simplify again, A squared, this one is positive times negative is negative AB or minus AB, plus AB, then plus times negative is negative B squared. So, if you notice, negative AB plus AB is equal to 0. So, cancel that one. So, the remaining is A squared minus B squared. And that is the proof. Okay, let's have another example. Let's have 100 raised to 4 minus 9n raised to 8. So it cannot be called difference of two squares if one of these terms is not a perfect square. So let's check first. 100 is a perfect square. The exponent of m is 4. If 4 is even, check. 9 is a perfect square. And exponent 8 is even. So check. So they are both perfect squares. So let's proceed to the factoring process. So again, step A, square root of 100 m raised to 4, and B, square root of 9n raised to 8. So square root of 100 is 10. Then 4 here, so you will not get the square root of 4, right? 4 should be divided by 2. So 4 divided by 2 is 2. So the answer is 10m squared. So make sure you have the perfect square table like 1 times 1, 1, 2 times 2, 4, 3 times 3, 9, until 25. So you have the reference. Or you can easily memorize and easily recall. Okay? Next, step B. N. 9. So square root of 9 is 3. Then N. 8 divided by 2 is, okay, correct, 4. So we will use this one to get the factors. So the answer is 10m squared plus 3n 4. Then the next factor is 10m squared minus 3n raised to 4. Again, it could be interchange. So this one will be the first factor and this one is the second factor. So no need to question one. Or I will write just so 10m squared minus 3n raised to 4 times 10m squared plus 3n raised to 4. So they are still the same. Let's have another example again. We have, so let's involve two variables like 16 m raised to 6 n raised to 10 minus 25 a raised to 8 b raised to 20. So again, step A, square root of 16 m raised to 6 n raised to 10. Then letter B, square root of 25 a raised to 8 b raised to 20. So square root of 16 is 4. Copy m. 6 divided by 2 is 3. Then copy n. N. So 10 divided by 2 is 5. We have also the next step, step B. So square root of 25 is 5. Then A. 8 divided by 2 is 4. Then 20. So 20 divided by 2 is 10. So therefore, the answer is 4m cubed n raised to 5 plus 5a raised to 8 b raised to 10. Then the next factor is 4m cubed n raised to 5 minus 5a raised to 8 b raised to 10. So again, the second factor can be also the first factor, so it could be interchange, right? Now let's involve fractions. So for example, we have 1 over 9 m raised to 10 minus 4 over 25 n raised to 20. So, again, step A, square root of 1 over 9 m raised to 10. Step B, square root of 4 over 25 n raised to 20. Okay? So, next. So, in order to get the square root, just get the square root of 1 and square root of 9. So, square root of 1 is 1. Square root of 9 is 3. And then, copy m. So, 10 divided by 2 is 5. Next, square root of 4 is 2. Square root of 25 is 5. Then, n. 20 divided by 2 is 10. So, the answer is the quantity of 1/3 m raised to 5 plus 2/5 n raised to 10 times the quantity of 1/3 m raised to 5 minus 2/5 n raised to 10. Have another example again. We have a raised to 4, b raised to 4. So again, step A, square root of a raised to 4. And then step B is square root of b raised to 4. So 4 divided by 2 is 2. So a squared, then b squared. b raised to 4. So 4 divided by 2. So you can say that a raised to 4 minus b raised to 4 is equal to a squared plus b squared, then a squared minus b squared. Now, we cannot stop here because this factor can be factored again. So, let's remain this one because we cannot factor this one through difference of two squares process. So, copy a squared plus b squared. Then this one from the previous example, so this is a plus b, then a minus b. So this is the complete factored form of a squared minus a raised to 4 minus b raised to 4. Alright. Last example. So let's have 160 m raised to 12 minus 250 n raised to 14. So if you notice, 160 and 250 are not perfect squares, but they are divisible by 10. So you can factor out 10. So it could be written as factored out 10. So use the factor of GCM, factoring the GCMF. So factored out 10. So 160 divided by 10 is 16. Copy m raised to 12 minus 25 n raised to 14 because 250 divided by 10 is 25. So now you can factor this one, right? So we have step A, square root of 16 m raised to 12, and we have step B, 25 n raised to 14. So square root of 16 is 4 m, 12 divided by 2 is 6, is 1. Square root of 25 is 5, then 14 divided by 2 is 7. So complete factor. So after this one, you will write 10 4m raised to 6 plus 5n raised to 7 times 4m raised to 6 minus 5n raised to 7. And that is the factored form.
1, 2,